Prepare for a mind-blowing revelation. IBM and NASA have joined forces to create an AI that can predict the sun's violent outbursts with unprecedented accuracy. But here's where it gets controversial. This AI, named Surya, is not just a tool, but a game-changer for space exploration and our understanding of solar activity. Surya, derived from the Sanskrit word for the sun, is a foundation model that processes raw images captured by the Solar Dynamic Observatory satellite. This satellite has been tirelessly observing the sun for over a decade, and Surya can analyze these images faster than any human ever could. Using this vast amount of data, researchers have developed a model that can predict solar flares and coronal mass ejections before they occur. This is crucial for protecting astronauts, space equipment, and even our power grids and communication systems here on Earth. With Surya, we've created a model that can look the sun in the eye and forecast its moods, said Juan Bernabe Moreno, director of IBM Research Europe for the UK and Ireland, who leads the scientific collaboration with NASA. As we venture further into space and rely more on technology, solar activity becomes an increasingly important factor. Solar flares and coronal mass ejections can disrupt satellites, airline navigation, and power grids, and pose radiation risks to astronauts. Forecasting solar storms is notoriously difficult, even more so than predicting storms on Earth, according to the scientists. When solar flares erupt, it takes 8 minutes for the light to reach us, and scientists need to be even more ahead of the game to make accurate predictions. The Surya AI model is similar to the Prithvi family of models, which process satellite data to create an accurate representation of Earth and predict its climate and weather. Surya, however, focuses on the sun and its dynamics. Surya is an open-source model with 360 million parameters designed to learn solar representation through various imaging channels and products. It can accurately forecast solar dynamics, solar wind, and solar flares, and detect extreme ultraviolet EUV spectra. The novel architecture of Surya allows it to understand the underlying physics of solar evolution. This is an excellent way to unlock the potential of this data, said Kathy Reeves, a solar physicist at the Harvard-Smithsonian Center for Astrophysics. Automating the process of pulling features and events from petabytes of data is a game changer. The model's data comes from the SDO, which orbits Earth and captures images every 12 seconds. These images provide insights into the sun's temperature layers, magnetic activity, and the speed and behavior of its magnetic lines. Researchers trained Surya by feeding it 9 years' worth of data, harmonizing the different layers, and experimenting with various AI architectures. They challenged the model to predict what the SDO would see an hour into the future, and remarkably, Surya learned to predict these quirks on its own, outperforming any human input. In testing, Surya could forecast solar flares an hour before they occurred, and in some experiments, it achieved predictions within 2 hours. This represents a significant improvement over existing methods, with a 16% increase in accuracy, according to IBM. The team has made the AI model open source, available on GitHub and Hugging Face, along with a curated dataset called Surya Bench. So what do you think? Is this AI a step towards a safer and more prepared future, or are there potential risks and ethical considerations we should be discussing? Let's spark a conversation in the comments.